Okay, for what we have in section 3.5 in this simulation, we have for problem number 1, we're looking at solving for x, whereupon the base 36 logarithm of x is equal to 1/2. And just some things to mention. Now, whatever we have in the attachment, okay, the attachment has to be a positive value. Okay, so you cannot have a base 36 logarithm of 0 or anything that is negative. So x must be positive. Also, regarding what we have for properties of logarithms, whenever we have identical exponential and logarithmic bases, if you have the base a logarithm of a to the x, that goes to x. And also, if you have a to the base a logarithm of x, again, you have another case of an identical exponential and logarithmic base, and that is also going to go to x. And this property we will use in creating the pathway to solving for x. So we have for the base 36 logarithm of x equal to 1/2. Okay, so the base a is going to be 36. And if I treat both sides of this equation as powers to which the base 36 is going to be raised so I have 36 to the base 36 logarithm of x. Okay, that is going to go to x. Now for 36 to the 1/2, okay, 36 to the 1/2, that is going to be the square root of 36. And for what we have in the outcome, okay, we have for this answer, okay, now we're going to have the x is equal to 6, and we have upon checking, and the result is correct. For what we have in the case of number 2, now we're looking at solving for x, and this time we have an equation. Okay, so we have the base 5 logarithm. We have of the quantity of 3x minus 7 is equal to 1. And again, whatever we have for 3x minus 7, 3x minus 7 has to be positive for that statement. That binomial is the attachment for what we have in this logarithmic term. Now, we're going to free up the 3x minus 7 from the base 5 logarithm. And again, we're going to apply what we just used for number 1. So we're going to have applying the exponential base, which will match up with the logarithmic base, and we'll treat both sides as powers to which the exponential base 5 is going to be raised. So we have 5 to the base 5 logarithm of the quantity of 3x minus 7 is equal to 5 to the first. And left hand side, okay, have 5 to the base 5 logarithm of the quantity of 3x minus 7. This will go to 3x minus 7. 5 to the first is equal to 5. And here we have a two-step linear equation. So upon adding 7 to both sides, and we're going to have that 3x is equal to 12. And we have with division by 3, we're going to have that x is equal to 4. And 3 times 4 is 12, minus 7 is 5. So the attachment is positive. And just entering what we have for x and checking out. And it is correct. Now, for what we have in problem number 3, okay, so we have in this case, all right, so we have 2 times the base 3 logarithm of the quantity of x plus 28 is equal to 6. Okay, and in this one, okay, if you notice, you have even number coefficients on both sides. And so what you can do is that we can divide the equation by 2. Okay, and just a little bit of a repeat. Now the attachment in the base 3 logarithm, okay, we have x plus 28. And whatever we have for x plus 28 must be greater than 0. So as you look at dividing by 2, we're going to have the base 3 logarithm of x plus 28 is equal to 3. And freeing up the x plus 28, Okay, so we have a logarithmic term with the base 3 logarithm. And I'm going to treat both sides as powers to which the exponential base 3 is raised. All right, so we're going to have, on the left-hand side, we're going to have x plus 28. And we have to the right, we have 3 cubed, which will be 27. And we have x plus 28 is equal to 27. And from this, we're going to have that x is equal to -1. Now, so while we cannot have a negative attachment, okay, now here x is a negative value, but the attachment has not x, but x plus 28. And so -1 plus 28 is 27, and that is greater than 0. And just testing out what we have. And the result is correct. Now, for what we have in the case of number 4, now we're looking at, it says to solve for x and round your answer to the nearest hundredth. Okay, so I have 7 plus 3 times, okay, the natural logarithm of x is equal to 2. And now we have a logarithmic term with 3 times the natural logarithm of x. And if I move the 7 over to isolate the logarithmic term, so you have the natural logarithm of x is equal to -5. And looking at, as we divide by 3, so we're going to have that the natural logarithm of x is equal to -5/3. Okay. Now keep in mind, a natural logarithm, okay, is going to be a base e logarithm. And before I get too far ahead, whatever we have for x, we need the attachment to be a positive value. Now we have for the natural logarithm of x, again, that's the same as a base e logarithm of x. And we have is equal to -5/3. And if I free up x from the natural logarithmic attachment, so I'm going to have e to the base e logarithm of x is going to be equal to e raised to the -5/3 degree. And so in taking what we have in the calculator, okay, so we have, with e, we have e to the x, and this is going to be to the -5/3. Okay, and so we have to the nearest hundredth, this will be to the nearest 2 decimal places. So you got a 0.1888. So to the nearest 2 decimal places, we have x is equal to 0.19. Then we have upon checking, and the result is correct.